your authentication needs go beyond what standard OAuth providers offer. FastMCP's provider interface lets you implement custom authentication logic while maintaining full MCP protocol compatibility. We'll demonstrate how to create a custom OAuth provider class that integrates with FastMCP's authentication system, showing the minimal implementation pattern using your own user and client storage backends. You'll see why most applications should prefer built-in providers like Auth0Provider or WorkOS AuthKitProvider for their automatic protocol handling, while understanding when custom solutions become necessary for specialized requirements. From FastMCP, import FastMCP. From FastMCP, server, auth, providers. OAuth import OAuth provider. Auth equals OAuth provider. User store equals your user database. Client store equals your client registry. Hash additional configuration. MCP equals FastMCP. Name equals auth server. Auth equals auth. This demonstrates the provider interface pattern, where FastMCP delegates authentication to interchangeable provider classes through its auth parameter. The example shows a custom OAuth provider that would integrate with your user database and client registry, while FastMCP handles MCP protocol integration, tool registration, and transport management. Built-in providers like Auth0Provider and WorkOS Provider require only minimal configuration, URLs, client IDs, secrets, automatically handling token storage, OAuth compliance, and protocol details. The pattern works through dependency injection, where any provider implementing FastMCP's auth interface can be substituted. For DCR-capable systems, like Auth0 or WorkOS, you use direct providers that handle dynamic client registration automatically. For non-DCR systems, GitHub, Google, Azure, you use OAuth proxy to bridge the gap between MCP's dynamic expectations and the provider's static registration requirements. This separation lets you focus on identity logic, while FastMCP manages MCP-specific concerns like metadata endpoints and token propagation. Custom providers should only be implemented when built-in options don't meet your requirements. For most production use cases, configuring existing providers with proper JWT signing key and client storage is recommended. The example's OAuth provider would need to implement specific methods like validate token and get user to work with FastMCP's auth system, making it suitable only for specialized integrations or legacy systems. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core server class that manages AI callable tool registration and execution. It handles serialization, request routing, and runtime operations while delegating authentication to specialized providers through a standard interface. The auth parameter accepts any provider implementing FastMCP's auth interface, from built-in solutions like Auth0Provider, requiring just URL, client ID, and secret, to custom implementations like OAuth Provider in this example. For providers without DCR support, OAuth proxy bridges the gap while maintaining OAuth compliance. From FastMCP, server, auth, providers. OAuth import OAuth provider. This imports OAuth provider, a custom OAuth2 provider implementing FastMCP's auth provider interface. In production, prefer built-in providers like Auth0Provider, which only require configuration, URL, client ID, secret, and handle token validation, user resolution, and OAuth compliance automatically. Custom providers like this example are only needed for specialized identity systems without DCR support, and must implement methods like validate token and get user. For non-DCR providers, use OAuth proxy to wrap existing OAuth services instead of writing custom providers. The auth parameter accepts any provider implementing the standard interface, from simple built-ins to complex custom solutions.
Auth equals OAuth provider.
This instantiates a custom OAuth provider implementing FastMCP's Auth interface, where OAuth provider serves as a placeholder for integrating with existing user databases and client registries. For production use, prefer built-in providers like AuthZeroProvider, which require only basic configuration, URL, client ID, secret, while handling OAuth compliance, token storage, and protocol details automatically. The Auth parameter injects this provider into FastMCP, enabling consistent authentication across all exposed tools while maintaining clean separation between identity management and tool execution.
User store equals your user database.
This specifies your user database implementation for token validation. The OAuth provider uses this store to verify user existence and retrieve metadata during authentication, while built-in providers like AuthZeroProvider handle the actual OAuth protocol flows with minimal configuration. For custom implementations like OAuthProvider, you must implement required methods, including validateToken and getUser, to match FastMCP's Auth interface.
Client store equals your client registry.
The client store parameter links your OAuth provider to FastMCP's client registry, which validates client credentials during token requests. This registry must contain all authorized client applications with their IDs, secrets, and redirect URIs. FastMCP uses it to reject unknown clients before processing authentication flows. For production use, prefer built-in providers like AuthZeroProvider. Requires just config URL, client ID, and secret, or WorkOS AuthKitProvider for enterprise SSO. These handle OAuth protocol compliance, token storage, and DCR automatically. Only implement custom providers like OAuthProvider when integrating with systems that don't support standard OAuth flows or DCR.
Hash additional configuration.
Placeholder for OAuth 2 provider configuration like token expiration, scopes, or custom claims. In production, use built-in providers like AuthZeroProvider. Requires just config URL, client ID, and secret, or WorkOS AuthKitProvider for enterprise identity. These handle token storage, OAuth compliance, and protocol details automatically. For providers without DCR support, wrap them in OAuth proxy. It bridges non-DCR systems to FastMCP's registration flow. The Auth parameter accepts any provider implementing the standard interface, from simple built-ins to custom solutions like OAuthProvider, which must implement validateToken and getUser. Always configure JWT signing key and persistent client storage for production deployments.
MCP equals FastMCP. Name equals Auth server. Auth equals Auth.
This instantiates FastMCP with a custom OAuth 2 provider through the Auth parameter, where OAuthProvider is a placeholder implementing FastMCP's standard Auth interface. In production, you typically use built-in providers like AuthZeroProvider for DCR-capable systems, or WorkOS AuthKitProvider for enterprise identity, which require only basic configuration like client IDs and endpoints while handling token storage, OAuth compliance, and protocol details automatically. For providers without dynamic client registration support, you'd use OAuth proxy with minimal additional configuration. The Auth parameter accepts any provider implementing the required interface, from simple built-ins to custom solutions, with the example showing how to inject a custom provider when built-in options don't meet specific requirements. FastMCP Authentication Interface. The Auth parameter accepts any provider implementing FastMCP's standard authentication interface, from minimal built-in solutions like AuthZeroProvider to custom implementations for specialized requirements. Auth0 Provider and WorkOS AuthKitProvider are the primary built-in options requiring only basic configuration: URL, client ID, secret, audience, while handling all OAuth protocol compliance automatically. For providers without dynamic client registration support, OAuth Proxy bridges the gap by presenting a DCR-compliant interface while using fixed credentials with traditional OAuth systems. The example's OAuth provider serves as a placeholder that would need to implement validate token and get user methods for custom authentication logic.
The authentication that disappears into the interface protects everything.